in this video I'm going to introduce you to R's data types, or the ones we're going to use very often, and also some functions and how the functions are used. So what I've done here is written some comments into a script with no code at the moment to help remind me what it is that I want to tell you. Okay, so to start with, R has different data types. So some data types are numbers and some are letters. So for numbers, something like the number 4 or the number 600, they are classed as numbers, and we can assign them just using the standard assignment X and then the alt minus to get that assignment operator, and then I'll use the number, let's do 23. So that number, when I run that code, control enter, will now end up in my environment here with the value 23 assigned to the value X. So I did not need to use quotes or anything for numbers. Numbers you can just refer to. You also have character data types. So I'm going to call this variable A, and I'm going to give it a letter. In fact, let's give it a word like love. And if I assign that with control enter, send that command, see it's run in the console down there, and now I've got a value up here, A, which has the word love in it. And for characters, whether it's a single character or multiple characters, need to have quotes around them. We also have these special values in R called logicals, and that's something that is a true or a false. I'm going to call it loggy here, and then I'll go alt minus to get the assignment, and then I'm going to type true. Now what you can see there, although this is a word, it's actually a special word in R, so that's why it's come out a different colour. So you can see with numbers are coming out, with my particular theme, it might be different for the theme you've chosen, but they'll still come out differently. My numbers are in pink, anything that's inside quotes is in this green colour or blue colour, and logicals are in orange. So if I was to do true, then you can see the variable loggy has the value true. It also could have the value false, so let me change that. You can see how at the moment it thinks it's a word, and as soon as I get to the end of it, it realises it's this special word or a special value, and is giving it, putting it in orange. Okay. So I'm going to introduce you to your first function now, and that's the str function. It stands for structure. I'll just type that in. And you can use this function on any of your objects that you've got in the environment, and it tells you what type of thing they are. So I'm going to put in here A, and if I run that command, control enter, you can see at the bottom, I just have to pull this up a little bit, it's telling me that A is a character with the word love in. If I do the same thing on X, it's telling me that X is a number and giving me the value of it. So str is a function that I use an awful lot. Typically I'll read in data, and the first function I will use is an str to look at what's in that data. So commonly use str. Now these are like single values we've got here, and often because we're working with data, we've actually got collections of values, so whole rows or whole columns of numbers that all pertain to the same thing. Let's say it could be 10 heights, for example, and you're going to want to collect those numbers together into a data structure, and that sort of minimal data structure is called a vector. So I can create a vector which collects together several numbers using a special function called C. And this is one of the only functions in R which has a single letter. And because it has a single letter, sometimes people get confused about it. It's just a function, just like str is a function. It has a function name and then a set of brackets. So to create a vector, let me call it vect of several numbers. I use this C function and I collect together numbers. Let's go 23, 12, 42, 19. Random numbers. I've collected those together, and if I run that, I've now ended up with this data piece called vect, which is actually a vector, and it has, you can see, 4 numbers in it. So it's a number, it's telling you, and then it's also telling you that there are 4 elements, or the indices go from 1 to 4. And if I do an str on that now, oops, vect, you'll see at the bottom it's reproducing the information you can see up here. So it's numbers, and there's 4 of them. So all functions have this basic format where you have the name of the function, an open bracket, and then you have the arguments. So in this case, vect is an argument, and then you have a close bracket. So most functions take at least 1 argument, and many functions take more arguments that you would separate with commas, and we're going to do that in a moment. So I've just done a vector of numbers. We can also do vectors of characters. So if I wanted to do several characters, so I could write, let's call it word. I could write the word love, but as separate characters. So I'm going to use C again. Because I am using 4 separate characters, all 4 need to be in separate quotes. So I'm going to have an L, an O, a V, oops, and an E. I'll run that and then I'll just mention a couple of things. So there I have something called word, which has 4 characters in it. So that's 4 separate elements of data, not 1 element of data, this is 1 element of data that happens to have 4 letters in it. So one thing I want to tell you about with the quotes here is R tries to help you out with brackets and quotes. So if you open some quotes, it automatically puts the closing quote in, and it will automatically put your cursor between the quotes or the brackets. So if I start to write this again, another word, let's say, and I go C, and then I open some quotes, you can see there, when I open the brackets and I open the quotes, my cursor stayed between them. And that's to help you not forget to put them in. So don't delete those when they appear. Now the other feature that helps you a lot, and it's a feature I absolutely love in RStudio, is that if you forget quotes or brackets, you can put them around the outside of things very easily. So let's say I'm going to create a vector of numbers, and they're going to be 2, 5, 6, 7. So just 4 numbers. Let's make it 5. And so here you can see it's complaining there. It's telling me something's wrong with this syntax. I need to collect together these inner brackets. So if I highlight those words and I go the shift and then open a bracket, instead of writing over, it actually puts the brackets around the outside. And this is a feature you get to love so much and use so often that it really annoys you when you're in Word and you do that same thing to put quotes around something or brackets around something, and you overwrite what you've got there already. So that would be the same if I wanted these numbers, let's put a C at the front there, if I wanted these numbers not to be treated as numbers but to be treated as characters, I could put quotes around them. So, and again, if I just highlight the word 2 and I do an opening quote it doesn't overwrite it. It puts the quotes around the outside. It's a fab feature. So I'm just going to put spaces in here because that's good practice. They're not essential in terms of the language, but it tends to make things easier to read. If I run that, now again I've got this another object or word, value, which has in it, although these are actually numbers, because I put quotes around, it's treating them like characters. Okay, so you wouldn't be able to do calculations on these because they're actually characters, not numbers. So we could also have vectors of logical values. So previously I just had a single value, false or true, and I can make that something longer. I'm going to call it logic. And I still need to use the C function to collect them together. But because they're these special words, I don't need to put quotes around them at all. So I can just say true, comma, false. Let's go false, true. Okay, so I've got 4 values there. And you can see there the type of value it is logi. It's actually telling you that it's a logical value. It's not just a word, a normal word. It's a special word. So normally we have our data in some kind of structure, and this is the minimal structure, the vector. And if we want to get information out of those vectors, say we only want one value, like the first one, then we have to index them. So I'm going to index this vector called vect. I'm going to index it and try and get out the number 12. And to do that, I have to use square brackets. So if I use vect, and then I open some square brackets, you can see that closing bracket is opened up as well. And if I use the index of 2, that will print out for me the number 12. There we go, at the bottom there's number 12. So the indices start counting from 1. So unlike Python, if you're familiar with Python, where you start counting from 0. So the number 23 has the index 1, the number 12, the index 2, the number 42, the index 3, and the number 19, the index 4. And you can index logical vectors and character vectors in exactly the same way. So if I was to use word, and let's say I want to get the V out, that's on the index number 3. I'll press that Control Enter to send the command. And you see it's giving me the 3rd element in that vector there. Similarly with the logic, as I've called it, if I use the index 1, it should give me the value true. There we go, I'm getting the value true. So this is where you want to select just a single value. Sometimes we want to select more than one value. So we might want to have the 2nd value and the 4th value from vect. So if I want the 2nd and the 4th, I'm going to need to give both the 2nd and the 4th index, but I need to collect these together in a C. Because I'm trying to give it 2 things to refer to one index, I need to put those 2 things together. So that means I want the 2nd and the 4th element. So there I have 12 and 19. If I do it without the C, the complaint I'm going to get is to do with the number of dimensions. 2, 4, because separated like that, it's going to assume that vect is something 2-dimensional, and you want the first row, the 2nd row and the 4th column. And so this is going to give me a complaint about dimensions. There you go. Incorrect number of dimensions. This is not 2-dimensional, it's 1-dimensional. So to ensure that both of those are interpreted as for the first dimension, single dimension, then you need to collect them together with a C. So here we've selected from vectors using indices, but we can also select from vectors using logical vectors. So if we look at using this vector here, and I'm going to select from that using the logic. So if I say vect and then use square brackets and give it logic, so what's inside logic is true, false, false, true. So what that's going to do is return 23, but not 12, not 42, and then it will return 19. So it's saying which of the values should be returned are the ones where logic evaluates to true. There you go. So I've got 23 and 19, the first and the last. Now this is something we use quite often. We may not explicitly make the logic vector, but we may have some condition in here which actually evaluates to a logical thing, a logical set of logical values, like above 20 or something like that. So for example, I can just do that now actually. So if I go vect greater than 5, oh, that's not a good one, is it? Let's do greater than 15. Oops, that's perhaps not, perhaps I should, yeah, my mistake. What I should do is something like this. So if I do vect greater than 15, this is going to return the values true or false depending on whether the value in vect is greater or less than 15. So there I get true, false, true, true. So if you look at your values here, 12 is the only one under 15, so that's come out as false. And then you might use that expression to select from your vector. So that would go inside the square brackets. Whoopsie, wrong brackets. And I'd put vect. So here I'm selecting from vector where the value of vector is above 15. So that's selecting for me everywhere where you've got a true. So the first, third and fourth values. What are you complaining about? I don't think it's got anything to complain about. There you go, it's gone away now, I've saved it. So a little bit more about functions. We have this function here, the mean. So the mean will give you the mean of some values, as you might expect, and it only works on numbers. So this will give the mean of those numbers inside vect. It's giving me a value of 24 there. If I try and use this function, whoops. If I try and use this function on another or on word, both of which are character vectors, it's going to complain. So there's the error message. Well, you get this NA, mean is not non-applicable, there's no such value, and then you get a warning telling you why that's not worked. Now this will give me a chance actually to talk a little bit about arguments in functions. So what I'm going to do is I'm going to create a vector which has an additional value in it which is non-applicable. So I'll call it vect2, and I'm going to have in it the numbers 3, 6, 1, NA. So this NA is a special value, it means not applicable. So it's not a 0, it's just a missing value if you like. So when I run that, I've got this thing of its numbers. It knows its numbers, but this number doesn't exist exactly. So I've got 3, 6 and 1. And if I try and calculate the mean on this vector, it's going to complain. So, well, it doesn't exactly complain, but you get an NA. So if you try and calculate the mean of a vector of values with an NA in, you'll get an NA as an answer. And the mean has an argument that allows you to cope with that situation, which is one that comes across up a lot, which is to exclude the missing values before you calculate the mean. And that is called NA.RM. And you can see how RStudio is trying to help me out here with the argument that I want. So I'm going to set that to true. So that means calculate the mean of this vector after you've removed the missing values. And now it will do that calculation, the mean of 3, 6 and 1. So this format for functions is what we use all the time. You have the function name, open brackets, and then each different argument in the function is separated by commas. So we have other functions here, which I'll perhaps leave you to try in your own time. There's a standard deviation you can try, and also the length function, which tells you how many values there are in a vector. But I especially want to talk a little bit about data frames. So at the moment we've got values which are in individual vectors. But very often we have data that's collected together into sets. So you might have several variables or vectors, if you want, in a single data set. And this data frame is the way we collect those together, and it's the most common unit of data in R. So it is the data structure that we use all the time. All the stats functions and plotting functions and so on use data frames as inputs. And we can create a data frame. I'm going to call it df, and I use this function data.frame, and then I'm going to give it the variables vect and word. There we go. And run it. And now you see that's come up here above in the global environment as data, and I've got something called df, and this is a data frame. So it's collected together these vectors. Let me click on that. I can get this spreadsheet-like view of that data now. Okay. So this is the sort of format that you're going to see all the time in R. And if you want to refer to one of these vectors, these don't exist except inside data frame. So to refer to those, you have to use this dollar notation, use df, and then a dollar, and then the name of the variable that you want. So that will print out vect for me. Okay, and that's where I'm going to finish this video.